everyone, in this video, we're going to determine if the given table is a linear function or exponential function. To better visually see the difference between a linear function and exponential function, let's see how their graph look like. Linear function is a function whose graph is a straight line. On the side, you will see a graph of a linear function. Please remember that a line has a positive slope if the line is rising from left to right. A line has a negative slope if the line is falling from left to right. A line has a zero slope if a line is horizontal, and a line has a undefined slope if a line is vertical. On the other hand, exponential function is a function with a positive constant other than 1 raised to a variable exponent x. On the side, you will see the graph of an exponential function. Please remember that the graph of an exponential function is not a straight line. However, this curve suggests that this exponential function grows quicker and quicker, or this exponential function decreases quicker and quicker. Okay, so let's look at these examples right here. Let's start with the first one. So as you can see on this table right here, the x is increased by 1. That means from 0, we actually add 1. And then from 1, we add another 1 here. And then from 2, it becomes 3. We're adding 1. And then from 3, it becomes 4. We're actually adding 1 each time. Now let's look at the y. As you can see on the y here, from -4, it becomes -1. And then from -1, it becomes 2. And then it becomes 5. It becomes 8. And it becomes 11. It can be seen that the y values are actually constantly added by 3. So from -4, we add 3. That becomes a -1. And from -1, we add 3. That becomes a +2. From +2, we add another 3. That becomes 5. 5 plus 3 becomes 8, and then 8 plus 3 becomes 11. This type of table right here is an example of a linear function. Now, we remember that if x increases by 1 and y increases or decreases by a constant rate, then the table is linear. So as you can see here, the x is increased by 1 and then the y is increased by a constant value of 3 each time. Then this is an example of a linear function. Now, let's look at the second example right here. So we are supposed to look at the x values first. So as you can see, the x is increased by 1 each time. So I'm just going to write that down here. Okay, now let's look at the y value. So from 81, it becomes 27. So this means that from 81, it was actually divided by 3. So 81 divided by 3 is 27. The other way to say this is that this is actually multiplied by 1/3. So that's times 1/3. So if we have 81 divided by 3 is 27, or we can do it the other way around. 81 times 1/3 is 27. And then from 27, if we divide 3 to that would become a 9. So 27 divided by 3 is 9, or again, we multiply that by 1/3. So that means 27 times 1/3 is actually 9. And then we also do the same thing here. We have from 9, it becomes 3 because it was divided by 3, or again, this was multiplied by 1/3. So 9 divided by 3 is 3. And then 3 divided by 3 is 1. Or again, we multiply that by 1/3. And then from 1, we divide that by 3. It becomes 1/3. Or we multiply 1 by 1/3. It becomes 1/3. This is an example of an exponential function. So I'm just going to write that down here. Now, we remember that if x increases by 1 and the rate of change in y increases or decreases by a consistent multiplier, then the table is exponential. So as you can see here, the x value is increased by 1 each time, while the y value is multiplied by a constant value, which is 1/3, or it was divided by 3 each time. So then we go ahead and say it is an example of an exponential function. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So as you can see on the x, each of the value is added by 1 each time. So I'm going to write that down here. Okay, now looking at the y value here, so from 13 it becomes 11. This was actually subtracted by 2 each time. So we subtract 2 here. So we subtract 2, and then from 5 subtracted by 2, it becomes 3. This is an example of linear function. We remember that if x increases by 1 and y increases or decreases by a constant rate, then the table is linear. So in this problem right here, this table is linear because the x is increased by 1 each time, while the y value is decreased by 2 each time. So that is an example of linear. Now let's look at the next example right here. So as you can see, the x is added by 1. So I'm just going to write that up here. Now, if we look at the y value, this is actually multiplied by 4. So from 5, it becomes 20. So this was actually multiplied by 4 each time. So 20 times 4 is 80. 80 times 4 is 320. 320 times 4 is 1,280, and 1,280 times 4 is 5,120. So that means this is an example of an exponential function because this was multiplied by a constant multiplier. We remember that if x increases by 1 and the rate of change in y increases or decreases by a consistent multiplier, then the table is exponential. So this is exponential because it was multiplied by 4 each time. Did you get the same answers as this? Good. Perfect. To wrap it up, we remember that a table is linear if the y value is either increased or decreased by a constant rate. So whenever it's either subtracted by a constant rate or whenever it's added by a constant rate, it is linear. On the other hand, a table is exponential if it is being divided by a constant value or it's being multiplied by a constant value. That's it. If you found this video helpful, hit like and subscribe for more math videos. See ya!